I am using my iPhone here on top of my document camera in the hopes that this does not all come crashing down for the now. So I'm going to go over our written computation assessment that we took today. If you're just interested in one of the questions, not all of them, I'm going to put up some links that you can click on to go to that question. So for this one, you can just skip ahead there. For this one, a link should pop up about right there. For this one, again, right there. And for this one, maybe right there. Or no, right there. Right there. Okay, yeah, right here. Okay, and then also in this area right here, we should have like a return to table of contents. So if you just want to check out like 2 and then go back, so figure it all out. I'm going to try and walk through each problem pretty slowly, so it's going to take a while. So if you're, we're trying to go in depth, right, not speed. I will solve each one with an algorithm, but at the end. So if you're just wanting to know what the answer is with the algorithm, you're going to have to sit and wait, and watch, see it visually, and kind of. I'm going to walk this through and think about it. Okay, so it could take a while. All right, so I'm going to use this piece of paper. It's white. Maybe you can see things better. And I need more room than what I have working. And so whenever I'm asking you to do an assessment in class, and I say you can get whatever tools you need to be successful, I mean it. If you need big pieces of white paper, get it. I am using scratch paper, so I am recycling. So this is damaged paper. I'm not using a brand new one. That would not be good. Okay. All right. So basically the first problem is saying, what is 3/5 plus 2/3? I don't know off the top of my head. I'm guessing since 3/5 is over 1/2, 2/3 is over 1/2. I know my answer is going to be more than 1. That I'm very confident in. It's going to be less than 2 because 2/3 is less than 1, 3/5 is less than 1. So there's no way it's going to be 2. So I know my answer as a starting off point is going to be somewhere in between 1 and 2. Okay, so I know that for sure. So if I get an answer less than 1 or an answer more than 2, I know I haven't done it correctly. I'm going to draw out the fraction using this ruler and a number line. And what I'm going to try and think about is I want to keep things equivalent. I want to keep them equal. I want to draw the same length number line for 3/5 that I do for 2/3. So what I'm going to have to do is I'm going to have to think about, and I want to do this easy. I want to make my life easy. I like making my life easy when it comes to thinking through things. So if something isn't going to be obvious, I'm probably going to skip it. And this is what I'm talking about. So if I'm thinking about thirds, I want to draw a line that I can easily split into thirds. So let me look at this ruler here. I'm going to pause a little bit, make sure the ruler, okay, it's there, cool. All right, so here's my centimeters. I got 1 centimeter, 2 centimeters. Can I split 1 centimeter into thirds? I can, but it's just not going to be easy. I mean, it's going to be like 0.3 centimeters per 0.33. And I really don't have a good enough ruler, and I'm not really wanting to do that. The other thing I'm going to be thinking about is I want to make, again, the same length line for each one. So I want to be able to divide by each number easily. Could I divide, again, 1 into fifths? I could, but again, too difficult. So I'm looking for numbers that are easily divisible by both 3 and 5. So here, I'll put the thirds down here. So I got 1 centimeter or 2. 3 is very easy to do the thirds because I just 3 divided by 3, right? I can do 1, 2, and there are my thirds. Is it easily divisible into fifths? No, because that would be 6. It'd be easy in 6 because I just have 6 spots here. 1, 2, 3, 4, 5, 6. We're not doing 6, we're doing fifths. That'd be too hard. I'm not going to try it. 4, no. 5's easy for fifths. All right, 1, 2, 3, 4, 5, but for thirds, that's too hard for me. 6 would be easy for thirds. So that'd be 6 divided by 3, so that's just every 2 centimeters. 1, 2, then I split it into thirds. But again, 6 divided by 5, no idea. No idea. 7, 8, no. 9, I can divide by 3. Get a whole, so that would be every 3 would be thirds. But again, 9 divided by 5, no idea. 10 divided by 3, I don't know, but 10 divided by 5 I know is 2. So that would work with fifths, but certainly not with thirds. 11, 12 would work with thirds. 12 divided by 3 is 4, so every 4 centimeters. But again, not with fifths. 13, no, 14. 15, I can easily do into thirds, because that would be 15 divided by 3 is 5. And I can do that with fifths. 15 divided by 5 is 3. Okay, so this is going to be this is 0. And this is 1. All right, that's cool. And my line is 15 centimeters long. So I'm going to draw 2 of those lines. I want to make sure they're exactly equal. Did I say evil? I meant equal. All right. See, this is, if you have any, that doesn't look exactly equal, does it? Maybe it's, sometimes that's a, here, what can I do here to prove this to myself? Well, so I'm going to flip it. I want to make sure I'm doing this exactly 100% equal. Sometimes they're optical illusions, and it's kind of weird that they come up like that. So what I'm going to do, I'm going to use my ruler, make sure it's flat. I'm going to do it this way. And I'm going to draw my starting line here. So that's going to be 0 for each line. Yeah? All right, so hopefully this works out. And we said 15 centimeters, right? So that's 1, 2. Oh, I don't like when that happens. 15. We're going to do another 15 centimeter line here. And hope upon hope that that looks pretty good. Awesome sauceum. Okay. So again, we're calling this 1. We're calling this 1. And both of these spots are 0, 0. Okay, so again, our first fraction is 3/5. So I want to make sure I am cutting up this number line from 0 to 1 into fifths. Okay, so to find fifths, I would do 15 divided by 5, which is 3. So that means every 3 centimeters, if I make a little mark here, so 3, 6, 9, 12, 15. So if I have my line here, here, I meant to do this in a different color. So I'm going to do, sorry about that, red. So here, 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 here. So this would be 1/5, 2/5, 3/5, 4/5, 5/5. I could continue, right? We can keep going. This one is going to be 2/3. So if I just want to split it into thirds, 15 divided by 3 is 5. So I would just count. I wouldn't do, again, we wouldn't want to do by 3 because that was the fifth. So this would have to be by 5. 5 and 10. And then 15. So this would be 1/3, 2/3, 3/3. Okay, so I have these are exactly the same length. I've split this one up into fifths, this one up into thirds. I have 1/5, 2/5, 3/5. So my first fraction is this one. So that's 3/5. And I'm adding on to that. Here, I'll fill this in. 3/5. And I'm adding that. What I'm adding on to that is 2/3. All right. So I have 3/5 and I have 2/3. Now, how am I going to add those together? What's going to make sense? I guess I could extend one number line and kind of measure and bring this up here and see if that lands on a 1/5. Or do that down here, bring this 3/5 down to here and have it. Let's do that. Let's see what happens. I'm curious. Very, very curious. Here we did the 15. Ooh, I'm gonna run out of room to 2, but okay, I'm not gonna worry about that because I know my answer is gonna be less than 2. I know it. So I'm gonna extend my number line. So if I extend my number line, and again, I want to make sure these line up. I want to be accurate here. Oops. 16, 17, 8. I'm just gonna go as far as I can and see where we end. So I'm just going to stop about there. So we need to extend this as well. Why does that look like it's curved? Probably is. And I stopped around 24. Okay. All right, so I had done this by fifths up here. If we remember, that was every 3 centimeters. So I'm going to keep going. So here's 15 centimeters. So 3 more would be 18. 3 more would be 21. And 3 more, hey, we ended there. I wasn't even thinking about that. Would be 24. Okay. And then if we're counting, this is 6/5, 7/5, and then 8/5. So this number line is going to 8/5. This one we were going by 5, right? Because we're dividing it into thirds. So 15, that would be 20. And then, oh, we're not going to have room. So we're only actually going to be adding 1 more to the thirds. So that would be 4 thirds. So let's see what happens here. If I remember correctly, this blue rectangle was 10 centimeters long. So I'm going to try adding that 10 centimeters up to here. And see where that gets us. Ooh, do you see? It ends there. Oh boy, oh boy. Man, so that's my answer, but what is that? It's somewhere between 6/5 and 7/5. 6.2/5, but that's not, we can't do fractions like that. Let me see if I add this rectangle, which was 9 centimeters, to this one down here. Oh, that doesn't look like it's going to work either. So that would be about here, right? So that's somewhere between 3/3 and 4/3. Which again, that's almost like 3.75 thirds, 3.8 thirds. What do you think? But you see these are lined up, so this is the same. This is the same. So 3/5 plus 2/3 is the same thing as 2/3 plus 3/5 on this number line that we've made. We just don't know what this number is. So what we have to do is we have to think of a number line with smaller units. so we can figure out what this spot is, because we don't know what it is in fifths. We don't know what it is in thirds. And it has to be something. It has to be, we want to be able to split it into the same. Okay, the same unit, each number line, so we can have some equality here. Let me think about this. Oh, wait a second. I originally did this as 15 centimeters, right? So I could split this into 15 15ths, right? Let's see if that works out here. Let's see if that works out here. So we have, let's see, 1 15th, 2 15ths, 3 15ths, 1/5, 4 15ths, 5 15ths, 6 15ths, 2/5, 7 15ths, 8 15ths, 9 15ths, 3/5, 10 15ths, 11 15ths, 12 15ths, 4/5, 13 15ths, 14 15ths, 15 15ths, 5/5, 1 whole. 15 divided by 5 is 1. 5 divided by 5 is 1. Numbers are awesome. 16 15ths, 17 15ths, 18 15ths, 19 15ths. So it looks like 3/5 plus 2/3 is equal to 19 15ths. Let's see if we get the same thing over here, just to make sure. I'm pretty sure we're going to, but you know what? Let's just make sure. So here we go. So again, 1 15ths, 2 15ths, 3 15ths, 4 15ths, 5 15ths, 1/3, 6 15ths, 7 15ths, 8 15ths, 9 15ths, 10 15ths, 2/3, equivalent. 11 15ths, 12 15ths, 13 15ths, 14 15ths, 15 15ths, equivalent to 3/3. 15 divided by 15, 1. 3 divided by 3, 1. Numbers are awesome. 16 15ths, 17 15ths, 18 15ths, 19 15ths. So this spot in between 3/3 and 4/3, and in between 6/5 and 7/5 is actually 19 15ths. So that's an answer. The answer to 3/5 plus 2/3 is 19 15ths. That's pretty cool. So what did I do there? I wanted to create a number line that was the same length for each of my fractions, and because I needed to make it the same length, I really had to think about how long I wanted to make it. I wanted to make it divisible, easily divisible by each fraction. We can divide anything by anything. I mean, I can take 1 centimeter and divide it into 17ths if I want. I mean, I would need a much more precise ruler and some patience, more patience than I have right now. So you can do that. But again, sometimes we want to make our lives a little easier. And when we think it through and plan from the beginning, now we have our answer. We have our answer of 19 15ths. So let's make sure using that algorithm that it's 19 15ths. What was I going to say? No, I think that's all I was going to say. Okay. So let's take a look at this as a algorithm. Check our work. We have 3/5 plus 2/3 equals. Again, we want to find the lowest common denominator, so that we think of multiples of each number. So if I think of the multiples of 5, I have 5, 10, 15. If I wanted to go up more, 20, 25. Multiples of 3, I have 3, 6, 9, 12, 15, 18, 21, 24. So I can see here that 15 does match. So I can turn it, 15. Hey, look at that. 15, 15ths. Yeah, are we getting there? So I want to then take my fractions and make them equivalent, changing the denominator to 15ths for each. Here I have 3/5 equals how many 15ths? If I multiply 5 times 3, I multiply 3 times 3, get 9 15ths. I multiply 3 times 5 to get 15. I do the same thing to that too, which is 10 fifteenths. And I add 9 fifteenths plus 10 fifteenths equals 19 fifteenths. There you go. So that was the answer we got. I would much rather you on an assessment do it this way. This really shows that you understand what's happening. I know it takes a while, but remember what we said, depth is way better than speed. You could do this and have no real concept of what's going on. You could do this, come up with 19 fifteenths, and not know 19 fifteenths was greater than 1, right? You could have that misconception. Here, it would almost be impossible for you to convince yourself that 19 fifteenths was less than 1. It's not, right? Okay, so now we're going to try doing this number 2, doing some subtraction. Okay, so now we're going to look at question number 2. 3/4 minus 1/3. Now, if you happen to watch the first question, I'm going to be thinking some of the same thoughts. So you may want to, you can hit, there's like a ×2 button down there, so you could go along at 2 times the speed. Because I know I'm going slow here, right? Slow, depth over speed, depth over speed. Thank you, Miss Bowler, Dr. Bowler, sorry for that. So I'm going to be doing some of the same thinking. So if you want to hear that thinking again, please sit back, relax, get some popcorn, make it an event. If you, again, had heard the thinking in this number 1, you may not need to stick this one out. So we'll see. We'll see what happens here. All right, so again, I'm going to be making 2 number lines. Actually, no, I'm doing subtraction. I'm just taking 1. So I don't need to do that first step that I did over here, where I wanted to make sure my numbers were going to be equivalent. The number lines, sorry. So I'm going to draw a line that I can easily divide into fourths. Now I'm taking away thirds from it, so I also want to be able to change. Whoa, sorry for that. That was not an earthquake, that was me shaking the table. I want to be able to take my 3/4 and I want to take away 1/3 from it. So I want to easily be able to see a third on my number line. So I need to think about that. I want to make sure my number line from 0 to 1, I don't need more than 1. I know my answer is going to be less than 1. Because 3/4, that's not 1. That's less than 1. 1/3 is less than 1. And I'm doing subtraction, so my answer I know is going to be less than 1. If I get a number over 1, I'm in big trouble. I've done something really, really not well. 3/4 is over a half. 1/3 is under a half. That could be around a half. It could be. Now I'm thinking about it. And this little squiggly line is mathematics for around or about, right? I believe so. So I think my answer is going to be around a half somewhere. So let's find out. We always want to do that first. We kind of want to think about what our answer is going to be. Give ourselves, think it through. Think through the process. Don't rush. Slow yourself down. Okay, so I want to draw a number line in centimeters that is easy to divide into fourths, and it's also easy to divide into thirds. So I'm starting here with 0, so I'm going to count it out and think about it. 1, no, I don't want to get into the business of breaking 1 into fourths. 2, I could, 1, 2, that's done for me. 1, 2, 3, 4, but thirds, that would be tricky. 3, I can do 3 into thirds pretty easily, but fourths, again, not easy. I can't see it right there. Fourths, 4, I can do 4 into fourths, but thirds, a little tricky. Don't want to think that much. 5, no for either one. 6, I can split 6 into thirds quite easily, but not fourths. 7, neither one easy. 8, I can do fourths pretty easy by 2, right? 1, 2, 3, 4. But by third, I'd be like, no, I'm not gonna, no. 9 by thirds, right? 3, 6, 9. But by fourths, it'd be like 2, 2.5, 2.5, 5, 7.5. No, that would be 10. Yeah, No, 10, so that wouldn't work. 10, I could do by fours, kind of, maybe thirds would be tricky. 11, neither one. 12, I could do by thirds, right? That would be 4, 8, and 12, and then I couldn't, wait, I could do by fours. 12 divided by 4 is 3, so I do 3. Okay, so we've got it. We're cooking with gas here right now. So this is going to be my 1. So now this number line is from 0 to 1. It's 12 centimeters long. So I can think about that and easily separate that into my fourths and my thirds. When I'm doing subtraction, right? Looking at that sign there, subtraction. I want to put my greater, my fraction that's bigger is always going to be on the left, at least in 5th grade. You may get into where it's on the right because there is stuff over here. There's a whole infinite area over here. From this 0 forever, you could count backwards into negative number land, but we're not going to be in negative number land right now. There's actually an imaginary number land too. I'm not going to get into that too much here, or at all, really. Okay, so I want to plot 3/4 here on this number line. So I want to divide this into fourths. 12 divided by 4 is 3, so every 3, I want to make my little thing here. 3, 6, 9, 12, and I have my 1, 2, 3, 4 equal parts. I have successfully divided this into fourths. Here, let's plot this. I should have done this. I see I messed this up last time. I think it's going to be really important to see these colors. So, edit, cut. I'm going to edit it, and then these are going to appear red. All right, see, voila. They're red now. And the line looks different because I made a mistake there. So if I look at this, this is in the 4 equal parts, so this would be 1/4. This is 2/4. This is 3/4. And this would be 4/4. So the fraction we're looking at here is 3/4. So that would be this part of the number line. All right, so that's 3/4. Now what I'm taking away from that is 1/3. So I could look at this, and again, oh, look at that. Oh, do you see what I see? Do you see what I see? Do you see that this is 9 centimeters, and I could easily divide this fourth into thirds? I wonder what would happen if I did that. I wasn't even thinking about that. I was just gonna like do this into thirds and see what. Let's do that 2 ways. So let's stay on this ride with me. Even if I'm wrong on this, we're gonna go live here. We're gonna see what happens just for the thought. So you see that from here to here is 9 centimeters. So I can easily divide this fraction 3/4 into thirds. But no, wait a second. Then I'd be taking 1/3 of 3/4 away. And I'm taking 1/3 of 1/2 away. So okay, so that might be useful later. That might be useful down when we do division. That's not gonna work out now because I would be splitting 3/4 into thirds, which is much different than splitting 1 into thirds. Do you see that? So if I split this 1 into thirds, so here would be, let's do this here. Here, 8, and then 12. So this would be 1/3, 2/3, 3/3, which would be 4 centimeters. If I split this fraction 3/4 into thirds, I would have it by 3. 1, 2, 3. So 1, 2, 3. Oh, it's already split into thirds. Look at that. Interesting. I wonder why that is. Why do you think this is already split into thirds for me? Because I thought these were fourths. This is getting really confusing, don't you think? But again, that's why. So if I took 1/3 away of the 3/4, that would leave me with 2/4. That would be the wrong answer. That would be a really easy mistake, wouldn't it? I'm like, well, I just take one of these 3/4 away. Oh, that's why it's easily into thirds, because there's 3 pieces. 1, 2, 3 pieces. 1, 2, 3/4. So that's why that would be the wrong thing to do. That would be the wrong thing to do. All right, so what I'm going to do here is I'm going to extend my line here. This is 1/3. This is 2/3. I'm not going to extend the line because I don't want to get all mixed. This is 3/3. All right, so we are taking 3/4 and we're subtracting from it 1/3. And so our answer, if you can believe it, is this. This area is our answer. How are we going to figure that out? How are we going to figure that out? It's like we need to split this up into smaller units. And what smaller units can we split it up into? 12ths, right? We originally had done 12ths. So let's do a different color here. I don't think I did my final green color in the last one, so I apologize for that. So let's see what happens here. So if I split this whole one into 12ths, right? So this is 1/12, 2/12, 3/12, which is equivalent to 1/4, 4/12, which is equivalent to 1/3, 5/12, 6/12, equivalent to 2/4, 7/12, 8/12, equivalent to 2/3, 9/12, equivalent to 3/4, 10/12, 11/12, 12/12, which is 1, 12 divided by 12, 4 divided by 4, 3 divided by 3. They're all 1. Numbers are awesome. So I wonder if we look at this area in 12ths, if we write this out, 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, 10/12, 11/12. So here, which is 1/3, that's equivalent to 4/12. Here, which is 3/4, is equivalent to 9/12. So it does look like we know now how much this area of 3/4 is, because we took away 1/3 of it, which is left with this area. So let's look. We start at 4/12 and at 9/12. So that's going to be 5/12. 1, 2, 3, 4, 5. 5/12. So this that's left over once we took away this 1/3 is 5/12. Let's see if that works out with the algorithm too. And again, I thought it was going to be around 1/2. It is. 6/12 is 1/2. 5/12 is a little less than a half, but it's around a half. So that feels pretty good too. So let's look over here. I should actually probably do these in the same color. So I started with 3/4. And I want to subtract 1/3. So again, just like we did over in the addition when we're doing the algorithm for subtracting decimals, we're going to look for that lowest common denominator so that it makes our subtraction easier. We start with the 4ths, so we list out multiples. 4, 8, 12, 16, 20. Now the reason, and I didn't do this over here, and I was actually thinking about it as I was working, I'm leaving some space here just so you can see when numbers line up where they would be in relationship. So I'm kind of pretending zeros over here. So the first multiple of 3 is 3. 6, which would be here. 9, right after the 8. 12, 15, 18. And so as we see 21, as we see the multiple that they both have in common is 12. So we can change 4ths and 3rds quite easily into our new denominator, the 12th. When we have fourths and we go to 12ths, we have to multiply 4 times 3. We're going to multiply 3 times 3 to get 9. Oh, I did the cardinal sin here. This is subtraction. We have 1/3 to change thirds into 12ths. Multiply by 4. Multiply by 4. 9 minus 4 equals 5/12, which is the same answer we got here. Again, if you didn't watch this first one, if you can show me this, this shows real understanding. This one doesn't. This one shows understanding of an algorithm. This one shows understanding of number system, how things work, and it kind of pushes your thinking. Much better way to go about things. All right, on to problem number 3. Okay, so now we're going to look at question number 3, which is 2 1/2 times 3. I took another little piece of paper off of that bigger one I was using. Recycling, reusing, reducing, not recycling. Okay, so we're going to look at this a couple different ways just to show it. We have 2 1/2 times 3. I know 2 times 3 is 6. I know 3 times 3 is 9, so my answer is going to fall somewhere in between 6 and 9. If it doesn't, I'm in trouble. There are some different ways to think about this. We could go, if you missed the pie charts, so here's one pie chart. To represent 2 1/2, I would need to, this is one whole, so 2 halves equals 1. I have 2 wholes, and I still need one more half. So this would be 2 1/2. Ooh, sorry about that. And I'm needing 3 sets of that, so I could just draw that out again. That's 1 set, more set. And we're looking for a 3rd set. I have 2 1/2. So if we count this all up, 1, 2, 3, 4, 5, 6. And then I have 2 halves, 7, and another half left over, 7 and 1/2. It's between 6 and 9, so I feel pretty good about that. Let's look at this a different way. Let's use a number line. I'm not going to be worried about the actual distance of my number line. Okay, so I'm going to go, here's 0, 1, 2, and 1/2. This is 1, this is 2. Yeah. 3. So we have 2 1/2 right here. So from here to here is 2 1/2. We need that 3 times. So let's extend this out. Again, I know it's going to be in between 6 and 9. So I'm just going to make my number line 9. So that was 2 1/2. If I start from here, wait, let's number this up. 4, 5, 6, 7, 8, 9. So we got 1, 2, 3, 4, 5, 6, 7, 8. Now remember, or if you were looking at the other 2 videos, I was going from 0 to 1. This is 0 to 9. Okay, so just so we're clear here. So that's one group of 2 1/2. I want another 2 1/2. So if we start from here, we have 1, 2.5 right there. Hey, that's right over 5. So two sets of 2.5 are 5. And then I want another 2.5. Which is here. So this was 2.5 as well. So if we look at the original number line, that is right at 7. Oops, 7 and 1/2. We could also look at that as 15 halves. And if we look at the algorithm, we have 2.5 times 3. We want to turn 2.5 into a mixed number and make our lives a little easier, so we're going to do a mixed number first. Or no, sorry, this is a mixed number. We want to change it to an improper fraction. I was at a conference, they said just don't use mixed numbers, makes life easier. 2 times 2 is 4, plus 1 is 5. So the improper fraction of 2.5, here, if we bring this back. 2.5 is 5 halves. So if you think about this, we have little markers on here that are halves. 1/2, 2/2, 3/2, 4/2, 5 halves. 5 halves, so that's equivalent. 5 halves times 3. So we want to change to an improper fraction. Then we want to change your whole number, or you want to make sure you have 2 fractions. Change to 2 fractions. You're like, but Mr. Light, 3 is a whole number. Much like all whole numbers have a decimal to the right of them, we just don't show it for efficiency. All whole numbers have a denominator. That denominator is 1. So we can change 3 to 3 ones. And then we simply just multiply. We don't have to do equivalent for denominators. We're just looking to go and multiply the numbers. So 5 times 3 is 15. 2 times 1 is 2. 15 halves, which again is the same thing as 7 and 1/2. And again, we can prove it down here if we want, because we do have halves as well. 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, let me do it up here because I don't know if that was on camera. 1/2, 2/2, 3/2, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves, 11 halves, 12 halves, 13 halves, 14 halves, 15 halves. 15 halves and 7.5 are the same thing. Yeah, cool. So 7.5, that's what we got over here. So looks good. And that's between 6 and 9. Super duper paratrooper. Okay, so we're going to take this 4 divided by 1/5. I hope the lighting and everything is all right. I'm doing this from home to finish it tonight so I can get it up tomorrow. All right. So what this is asking is how many 1/5 are there in 4. So let's find out. I'm going to go back to my number line. Here, let's hope you can see this. So I'm going to start about right here. So I'm going to mark this as 0. And I want to get to 4, splitting it up by fifths. Okay, so if each line represents a fifth, so that's a 1/5, 2/5, 3/5, 4/5, 5/5, which we know is 1. 6/5, 7/5, 8/5, 9/5, 10/5, which is 2. How much is 10 divided by 2? Hey, numbers are awesome. 11/5, 12/5, 13/5, 14/5, 15/5, which is 3. Good times. Uh-oh. Did I do this perfect? I didn't even mean to. 16/5, 17/5, 18/5, 19/5, 20/5, which is 4. So when they're asking us how many fifths are in the number 4, our answer is 20. 20. So let's look at that. We can do the algorithm here. 4 divided by 1/5. We take the reciprocal of this fraction, and reciprocal means that we turn it upside down. So that, and then we multiply. So 4 times 5 over 1. We could also look at that as 4 over 1 times 5 over 1, which equals 20 over 1, or just 20. So again, when you're doing this, the algorithm, but again, this doesn't show knowing. This shows you know how to do an algorithm. This doesn't show me you know the math. This just shows me you know the algorithm. But again, the step, so the algorithm is a good way to check, really, when you get down to it. It should only be used for checking. Maybe that's all I'm going to have you do from now on. What do you think about that? You have to use two different ways. One can be the algorithm to check your work. Good times. I love it. I love it. What do you think? You guys excited about that? Ladies and gentlemen? All right, so that first thing that you do is take the reciprocal. And then you multiply. And there you go. All right, so those are your answers. Hopefully you got it. If you have any questions of anything I've done, message me. I don't think you can leave comments because you have to have Google+, but email me, talk to me in class, do something. All right, have a wonderful time whenever you watch this. Could be in the morning, could be in the afternoon, could be a Saturday. Don't know, but have a great day, and I will talk to you later.